Okay, great. Welcome all to the session or roundtable on data preparation for machine learning. And I'm Xu, and I'm a faculty member in Georgia Tech, and I'm co-chairing the session with Zia, a faculty member at Leibniz University of Hanover. And we're grateful to have four panelists with us: Renee, Paulo, Yeye, and Juliana. And we'll let them introduce themselves a little bit later. I'm gonna give a very short introduction to the topic, and then we'll have our panelists introduce themselves and their research, and then we'll open that for discussions. Okay. All right, so the topic is data preparation for machine learning, right? So machine learning is, nowadays is used everywhere in many, many different applications. For example, in retail, right? Machine learning is used for customer churn predictions, for product recommendation, for product pricing, and so on, right? For example, in healthcare, machine learning is used for disease diagnosis, prognosis, treatment recommendations. In insurance, machine learning is used for fraud detection, and so on, right? Not only machine learning finds many applications in real world, but also in academia, machine learning has also penetrated a lot of disciplines, even within computer science. For example, in database community, we've been seeing machine learning being used for tackling traditionally challenging database problems, such as query optimization, cardinality estimation, and also for data cleaning and data preparation, right? Given the widespread applications of machine learning, it's natural to ask, right? So what do people do when they're building a machine learning or data science applications? And I'm sure that many of us are not unfamiliar with this survey that basically asks data scientists, what is the most time-consuming job and what is the least enjoyable job amongst all the kind of things that need to do in order to build data science or machine learning applications. And it is not surprising that a lot of their time are spent on sort of data preparation, right? Including data collection, cleaning, organizing their data, instead of actually, building machine learning and the data mining models, right? And also data preparation is also the least enjoyable aspect of their job, right? So the question is, so why do they spend a lot of time in data cleaning or data preparation, right? Can they just, use lots of labeled data and leverage, state-of-the-art deep learning models so that they can be very robust to data errors? So why don't they just do that? Another survey shed some lights into that question. It turns out relational data is still the most commonly used type of data in machine learning applications, despite the buzz around the deep learning on image and the video data and so on, right? So relational data is still the the major or the most commonly data type used in machine learning applications. And we all know that there are many numerous data quality problems in relational data, including data formatting issues, inconsistencies, data duplicates, misalignment, and so on, right? And all of this can affect downstream machine learning model quality significantly. And similarly, right? So people ask, oh, what is the most commonly used machine learning model? Well, it turns out that it's not, deep neural nets, right? It's rather those kind of simple models, such as just regression and decision tree, that are reportedly being used the most by machine learning scientists. Perhaps for their interpretability, perhaps for their, other properties that they possess, but in reality, those simpler models can be used more often. And we all know that those simpler models are more susceptible to data noise in the input training data, right? So this motivates sort of the generic work in the area of data preparation for machine learning. And we prepared a couple of questions that we can, hopefully can initiate this conversation. But before we do that, and I think it's worth taking time to let our panelists introduce themselves and their research. And I know that all of them have done great work in the generic area of data integration, data preparation, cleaning, and so on. Right. So, and I've ordered this alphabetically. And after this, I'll let Dia sort of moderate the discussion. I also participate in any way that I can. Okay, Juliana.
Hi, so can I share my screen?
Of course.
Okay, just a sec. Oh, it says you have to unshare first.
All right, let me do that.
Okay. All right, so my name is Juliana Frady. I'm a professor at the New York University, and I've started to work on data preparation and then data cleaning as a necessity for a number of the projects I was involved with. Right. So I think that one of the big challenges that I encountered when I was using urban data and needed to analyze the data. But before I could analyze, I should clean it. And when I found problems in the data, I had to transform and curate and so on. And that's when I came to the realization that although we've had a lot of research on data cleaning and curation in our community, when it comes to tools and libraries to actually assist us in doing it in real life, we fall short, right? So there's very few primitive systems libraries that we can use to support data cleaning. And this is what motivated some of the work that I've done on building systems that support data cleaning and curation. One of them is called Vizier. It started as with the goal of making it easy to do complex cleaning operations, but it evolved into this idea of data-centric notebooks. But let me focus on just the data curation part. So with Vizier, the vision was that data preparation is actually an integral part of data exploration, right? So we started with data cleaning as this idea of data warehouses where you get a bunch of data, you clean, load in their warehouse and analyze it. Now, more and more what people do is you have lots of open data and people will do data cleaning for whatever task and analysis that they have at hand, right? And as they explore data and they understand data, they find issues and they have to incrementally transform and clean the data, right? So the idea of Vizier is to help and support users in this iterative process of analyze and clean, right? So it supports exploration, validation, and transformation of data. And very importantly, it has built-in support for provenance and reproducibility. And provenance here, it captures both the fine grain at the data level, at the tuple level, as well as the transformation steps, the coarse grain provenance. More recently, we've been working, and again, when we are working on Vizier, right, so we build this whole infrastructure, but what you really need in order to do these, to do cleaning is, primitives, basic functions that do entity resolution, that do normalization and so on, right? So again, we're missing infrastructure to support that. And Heiko Miller, who was at NYU, started to work on this idea that we're calling Open Clean, which is a Python library for data profiling and cleaning. And the goal is to have an extensible library, just like, scikit-learn, but for data cleaning, where, as people write nice research papers, develop new methods, they can easily integrate that into this library, right? So, my vision is that the same way that systems like scikit-learn helped push the area of machine learning forward, I believe that having something like this for data cleaning would be very useful and could be transformative, right? So Open Clean is done in Python. Because it's in Python, you can actually leverage the whole Python ecosystem to explore, validate, and transform data. Combining it with scikit-learn, pandas, Jupyter, and so on. Just like Vizier, it also has support for provenance and reproducibility, and it was designed to be extensible. So, for example, as a proof of concept, Heiko started by integrating Metanome with the system. And, ideally, we would see a number of other systems that we've developed in our community, like HoloClean and so on, integrated here. So I would like to call people, if you have primitives for data cleaning and curation, try to integrate that on Open Clean. We'd be happy to help. And of course, if you have any feedback on the system, we would also appreciate that. Very quickly, so these two systems are kind of like generic. They work for ML, but they work for everything else, right? So when we think about machine learning, I think one big step that community made was this idea of democratizing machine learning through the use of AutoML. So the idea of these systems is that, given data, a task, and maybe some time constraints, these systems will automatically generate complex machine learning pipelines, right, from data preparation to the actual learning primitives. And in my group here at NYU, we developed a system called Alpha D3M, which is an AutoML system inspired by AlphaZero. And what it does is that by trial and error, it learns how to synthesize end-to-end pipelines. Again, from data preparation to learning techniques, right? So the idea is that it keeps trying different primitives. It works off a library of primitives, and it keeps, trying them and testing the pipelines until it learns, what are the successful combinations of different primitives. And it does that by exploring different preprocessing and encoding strategies, imputing, encoding, and so on, as well as different learning techniques. For usability purposes and also to open the black box of these AutoML systems, we've also developed a tool called Pipeline Profiler that allows users to interactively explore the AutoML pipelines and obtain insights into how to improve models, select the most suitable pipelines, right? Including finding what primitives are actually helping obtain good performance of the machine learning models, right? So, so that I don't go too much over time, I just added some notes in terms of, thinking back about this work and thinking forward about what I think still needs to be done in terms of the data preparation. I think that provenance and reproducibility are key concerns for data preparation, not as an end goal, but because they are essential and needed for us to be able to debug and build trust on these pipelines that include data preparation. And more importantly, it's only through reproducibility that we can actually test these pipelines for fairness and biases. Another important area that I think needs a lot more work is this issue of explainability. We've seen a lot of people talking about explaining machine learning models. But as Sue mentioned, most of the work is actually the data preparation. So I think that we need to think more broadly, and we need to think about explainability for computations and data preparation. Another very important point that in practical applications, although AutoML is great, we need the human in the loop because I can generate a pipeline that does great preparation that achieves very high F measure, but it actually produces the wrong result, right? So I think that the big challenge here is how do we support domain experts that don't have training computing? And we made some strides towards that, but I think there's lots of open problems there. Right. And last but not least, I think that as a community, we have a great opportunity here to have practical impact. We should put our research to use, and we should integrate the techniques that we develop into open source libraries so that they can actually be used in real applications. And with this, I close, and thank you.
Thank you. Thank you, Juliana. Yeah, you want to go next?
Yeah, sure. Let me share my screen. Okay, can you guys see?
Yes.
Yes.
Okay, great. Okay, so hi everyone. I'm Ye from Microsoft. I'm really happy today to have the opportunity to share our thoughts on this topic of data preparation and ML from the perspective of the industry. So data preparation. Well, I think many of us would agree that this is a really broad term, right, that touches upon many different aspects of the entire life cycle of data, data discovery, data transformation, matching, cleaning, validation, etc. So clearly, there's a lot of interests from the academia and the industry. Doesn't matter how you count, right? Number of papers, startups, new products, etc. And I'm sure Juliana's Open Clean should actually be on the list soon. So like anything that has something to do with ML, it actually goes both ways, in my opinion, right? So you can have machine learning for data preparation, but also data preparation for ML. And so in this short presentation, let me share from our own experience at Microsoft using one example on each of these two topics. So the first is ML for data prep. And broadly, we want to use ML to help data preparation. And I want to highlight that this is especially important for end users in places like Excel and Tableau. So why is this important? Well, first of all, there are billions of such users out there. And unlike your PhD level colleagues who are code ninjas, right? These people, they are less technical. And the vast majority of them cannot code to solve their own data problems. And as we look to democratize data analytics and machine learning, I think these people especially need our help. So let me give one example here, which is the problem of detecting data errors in Excel spreadsheets. Unlike data experts who may be able to use sophisticated first order logic like denial constraints or functional dependencies to detect errors, Excel users typically rely on their own eyeballs, right, to find errors in spreadsheets manually, because they don't really know how to program those complex constraints. And even though there are lots of pioneering work in our community, including many from panelists like Zia and Xu here, that are very influential. But from the perspective of Excel, it's not really a very good fit, because if you look at these 1 billion Excel users, they can't really program those constraints. So that kind of motivated us to look at the problem of unsupervised error detection in spreadsheets without using any input in the form of constraints or labels. So clearly there's no magic, there's no panacea, and we cannot be expected to go fully automatic while still having very high precision and recall at the same time. So in the setting of Excel, we need to be very high precision so that we don't annoy our users at the cost of a reduced recall. And that's okay, because there's no good alternative right now for end users today in places like Excel. So these unsupervised technologies we developed a couple of years ago have actually already been integrated into Excel Online. They are running in dark mode today, and thanks in large part to collaborations from MSR Asia. And so if there's some lesson I could share from this example, I would really want to bring people's attention to end users, right? I think we stand to make a significant impact on this world when we look beyond our PhD level users as our only customers and look at this large use base of people who work in Excel and Tableau and other places. So, okay, so that's ML for data prep. Now let's look at it in the other direction, using data prep to improve ML. The one example I would want to mention is to automate data validation in ML pipelines, which is commonly known as ML ops today. So why do we need this? Well, there are a lot of recurring ML pipelines these days. And if we look at places like Google and Bing, right, there are a complex web of data pipelines that take upstream data and cook them into data feeds that can be used downstream to retrain ML models every day. So we have lots of long-running and recurring data pipelines, but data quality issues can creep in over time, right? For example, you can have schema changes where you may have a missing column or an extra column. The distribution of your data can change, and the code that generates data can also change. And these data quality issues can cause your pipeline to fail silently, polluting your downstream data feeds and also your data machine learning models. So we want to be able to validate data in these pipelines and catching any data quality issues early as they arise. So pioneering work here include ones from Google and Amazon, and they design a very nice domain-specific language, or DSL, that allow users to easily program data validation constraints. So in this example, developers can write this script to require, for example, this review ID column to be unique, this marketplace column to be complete, and values in the marketplace column has to come from this list of 5 values, for example. Now, what we believe is that although these DSL-based approaches are a big step forward, they are still quite difficult to scale, because ML engineers and data engineers today, they have to deal with hundreds of production data feeds, each of which in turn also have hundreds of data columns. And programming these constraints manually, one column at a time, clearly would not scale. So I would not get into the details of how we at Microsoft were able to automate a lot of these. But the point I want to make is that for machine learning in production, accuracy is only one optimization objective. And it's not the only game we can play, right? There are lots of other dimensions that are equally important, such as efficiency, reliability, user productivity, and things like inclusion. So I believe we as the data people would actually have a lot of unique perspectives to offer here. So I talked about one example on each of these two topics. On ML for data prep, personally, I feel very compelled to help the billions of less technical end users out there using our research. And once again, because these users cannot write custom code to solve their data problems, the need for us to help them is especially strong. And we really stand to make a very big impact here. On data prep for ML, the users we talk to would be very different, right? And these are PhD level users with diverse backgrounds in machine learning, statistics, programming, etc. And this is a very high value market, but also raises the bar for wide adoption, because practically these users can solve anything using custom code. And we really need to address big pain points that help a large fraction of those users before they are even willing to try something we have to offer. So I think, to summarize, I think we as the data people, we actually have a lot of opportunities in this space. And personally, I think this is an exciting time for data preparation. So that's it. Thank you.
Thanks, Yaya, for the examples and the introduction. We have Renee, and then followed by Paolo. And it's a bit unfair to say, but we'll ask these remaining two panelists to be a little bit, shorter on the introduction, so that we can have more time for the discussions later on.
Excellent. I'm happy to do that. Two slides. So I focused on two of the 6 questions that the chairs asked us to look at, the first and the last. So let me talk about what I think is some of the differences between traditional data prep and machine learning data prep. So data preparation for analytics is absolutely crucial. Curation is known to be critical since the accuracy is queen. You have to have good, clean data on which to make your analytic decisions. And it's a bit unfortunate that the curation panel is at the same time as this panel, because if somebody were to ask me what the difference between data prep and curation is, I would not be able to answer that question. So I'm going to kind of use them in the same way. But I think we all agree that curation and data prep is absolutely critical in many, many traditional database applications. Now, data prep for ML. People in machine learning would argue often that their approaches are designed to handle noise. So do we even need data prep, right? I was on a panel at KDD in 2019 with Andrew McCullum, and he was arguing that data integration is no longer needed because heterogeneous data, that's just noise. And if you have a good enough machine learning algorithm, it can handle that noise. So why do you need to integrate the data? Why do you need to clean it beforehand? And so a lot of the deep learning evangelists would say, no, you don't need data prep. If your machine learning is good enough, it's good enough to handle the errors and other things that happen in real data. Of course, I'm a database person, so I disagree. And I don't think machine learning has solved the garbage in, garbage out problem. So if you're training your data, if you're learning on data that hasn't been well prepared, that has a lot of errors in it, that hasn't been integrated, I think your models are not going to be robust. And there's lots and lots of examples of this in the literature, and I'm going to be self-servingly, since the chair has told us to be self-serving in the intro, point out one a piece of work by my group. In a EDBT paper this year that got the Best Paper Award, we looked at how do you disambiguate data lakes. And so the disambiguation is a data preparation process where we're trying to figure out, does CA in this table mean the same thing as CA in this table? And one, it might mean California, and the other, it might mean Canada. So we were looking at this problem, and we needed to illustrate to the reader why it's an important problem. And so we took a state-of-the-art unsupervised domain discovery approach from Juliana's group that had been published just the year before. And we actually showed that the accuracy of this approach, which is excellent, does deteriorate as you inject ambiguous values. And perhaps that's not surprising, but it says that you need to understand how ambiguous your data is, how clean your data is before applying these different machine learning approaches. And I could have used 100 different examples here. It's been shown that the machine learning approaches do depend on data characteristics. So the second problem I wanted to talk about was the last question that the chair has asked us, which was, is data preparation a database problem or a machine learning problem? And I'm going to argue both, but I'm going to argue that the database approach here is absolutely critical and it's understudied. So when you read machine learning papers, if you look at their performance, their focus usually is on ablation studies, right? Where they remove one component of the system in order to understand the contribution of that component to the overall system. And you rarely see machine learning papers without some kind of ablation study in them. Whereas database, our performance has always focused on benchmarking, right? And so we vary the characteristics of the data or the workload in order to understand the performance of the system over different types of data, right? And so here I'm going to focus on the data rather than the workload, since machine learning systems aren't query processing systems. So if you think about all the great the benchmarks and databases, if you think about TPC, one of the most crucial parts of all the different TPC benchmarks is the data generator, where the data generator varies not only the size of the data, which is of course important for database people, but the characteristics of the data. How much skew is in the data? How much duplication is in the data? Other important characteristics that can affect the performance of the database management system. In addition, in our community, we have, in my group, we developed iBench and BART in collaboration with Paolo, who's on the call here. And these are data generators, or in the case of iBench, a metadata generator, for understanding the performance of data integration systems, data exchange systems, where we generate data and metadata that has different complexity in terms of how heterogeneous it is and how hard the integration problem is. Similarly, BART generates data for understanding data cleaning. And we can generate data that has low complexity errors or higher complexity and a higher number of errors in it. And these types of systems are really important for understanding the performance of integration, of cleaning systems. And I noticed that Felix Neumann in the intro to the conference said that they had explicitly added benchmarking papers to the BLDB 21 call because of the importance of these in our community. And I think when it comes to data prep, we need more of this. When it comes to machine learning, we need more database style evaluation of these solutions. There's too many ML papers that are run on 2 data sets and a victory is declared. And there's not enough thought that goes into, well, what characteristics of the data, what bias in the data, might make the machine learning technique not work as well, and things related to fairness, things related to incompleteness of the data. How incomplete can it be before the technique starts to deteriorate? So I think we need more. So, and I'll end there, and I hope I didn't go over time. So let me stop sharing.
Thanks, Renee, for the very interesting perspective. We'll have Paulo.
Yes, I'm ready. I'm gonna try to share my screen. It's coming. Can you see the screen fine?
Yes.
Okay, excellent. So hi, everybody. I'm Paolo Papotti. I'm a professor in France at EURECOM. And today I'm glad that I'm last because my colleagues gave already fantastic introductions to the problems from many angles, because I'm gonna talk on something that is slightly different in some aspects. In the last 2 years, I've been looking a lot at the boundaries between relational data and text, with some emphasis on deep learning for NLP and how these techniques can be used for data preparation, but also what is the role of structured data in this application involving NLP. So today I'm gonna give you a couple of examples in these lines. And the first one is about using deep learning for relational data integration. And the second one is gonna touch on fact-checking and the importance of data preparation also beyond data cleaning, because we are, at least in this crowd, I believe we are obsessed. We have been working so much on data cleaning, but I think that there are also other angles that can be interesting. So for the first application, I'm not going to go into the details of the paper. It is about using embeddings. So the setting is that we have a relation or multiple relations. We want to integrate them as a schema matching or entity resolution setting. And there is a solution such that we can obtain this in an unsupervised way. And the key intuition is that we want to rely on embeddings, which is this representation in a low-dimensional space coming from the NLP literature. And the way to obtain them is that we represent the relational data as a graph of values in the cells and columns and rows. We create embeddings with some procedure, and then we can do entity resolution, schema matching, just by looking at the representation of the metadata. Okay, so that's the idea. You can get all the details in the paper. And what I want to stress today is that in preparing the data for this application, we found out that there are some aspects about treating the text that are extremely impactful. So as I mentioned, in our graph, we create this representation of the cells. So for example, this is the title of a movie. It will be the content of a cell, and it's connected to some other nodes, the record ID and the attribute. We discovered that basically the representation of this token with alternative encodings dividing the long text into short tokens of 1 gram, keeping the union of the different representations and many other variants, they have a huge effect on the target application, in this case, the embeddings for data integration. Specifically, you can see that the simple representation of text goes from an F measure of 50% for entity resolution up to 86, 59, 81. And we have many examples of those, especially for data sets that are very challenging in data integration because they contain long text. That is something that has been recognized in the entity resolution community for some time, and apparently this tokenization, so the preparation of the text, has a very big impact in our experience. Another angle that I think it's interesting, it's coming from the application of fact-checking textual claims. So this is a process where you have a sentence with a factual claim, and in this instance, you have some relational data available. You want to verify the claim against the relational data. So why I'm mentioning this? Because in our work, we took an approach based on query generation. We have some solutions for this. You can find the details in the paper again. And the idea is that we want to generate a query that is equivalent to the claim to say, okay, this claim is true or false once we run the query over the data that is provided. Okay, but what I find really interesting here is that there are tons of baselines that are coming out in the last 2 years that are based on neural methods. So what they do is that they try to create a model based on transformers, for example, where they encode together the claim or the question for question answering and the data. And this is a very challenging problem of data preparation for me, because it's not clear at all what is the right representation for textual data and structured data with data metadata at the same time. So here is an example on top of a transformer where you have the claim, the text with a simple separator, and then the tokens that are just flattened out. But there is a lot of evidence that this serialization and the different alternatives in representing the data can make a big impact. Here is another paper where they show that you can have a simple serialization, or you can try to create sentences, meaningful sentences out of the database. And the second one is going to be, of course, much more natural as a representation for a model that has been designed to handle natural text. So I think that those are fascinating challenges, and I will try to talk more about this in the following discussion. Thank you.
Thanks, Paulo, for bringing the discussion of data prep on text data as a new kind of a perspective. I'll start sharing my slides again. Zia, I'll let you try to moderate.
Okay, great. Thanks for all the introductory talks. I think we have touched a bunch of the questions that we had in mind to ask. But I would say, instead of going through the question as listed, it's just to keep the roundtable nature alive. We should just right away go to the question that is in the audience. So Arun is pointing out the question on benchmarks and why we are not having that as in comparison to other communities. And he's bringing up 2 points. I don't know if you want to talk yourself, Arun, you're invited. Feel free to just talk. Yes.
Yeah, sure. I mean, I saw a question from Juliana before me. Renee, she has
I see. Oh, I'm sorry. I missed that one. And maybe just go ahead and then we
Yeah, so for Juliana, the comment at KDD was it was more general, including structured data that not being needed. That if you design your machine learning algorithm in an appropriate way, even if facts were represented in different ways, no entity resolution and so forth, that was kind of noise in the machine learning that a machine learning algorithm could take care of. So that was the comment. It was on a panel, and I think it was made to be controversial.
I'd say, yeah, so I kind of like tend to agree with the comment if we think about images and text. When we move to structured data, I think it's different.
Yes, I agree. I completely agree.
I mean, even in image and text, there are data preparations involved. For one thing, data labeling, is data preparation for sure, and they need lots of labeled data. Although from text perspective, how to get the right embedding, as Paulo pointed out, right, is also kind of feature kind of preparation that's specific to text data that we also need to care. And the machine learning has focused a lot of algorithms, and the systems perspective could be very helpful in terms of usability and the scalability of those kind of preparation pipelines.
Okay, we follow up with my question, Renee, for you. The benchmark stuff. Why is there no big benchmarks in this space, even though we've been working on this space for like 20, 30 years now? This was also the focus of the Sigmod panel discussion. Ihab was there, Joe Hellerstein didn't join, but he joined the Office of Data. Luna was there, Ihab Ilyas, Felix Naumann, and Sarah Catanzaro was there. So the main takeaway I got from what they were saying is, well, people didn't really understand real world use cases enough. And it was originally very theoretical and stuff like that. But now in the last 5 years, AutoML platforms have really accelerated, and they're claiming they've automated data prep, like SageMaker is claiming this, TFX, AutoTFX is claiming this, Salesforce Einstein is claiming this, and we all know it's all bogus. And so the only way we can expose that it's bogus is with benchmarks, which show that here's a suite of data sets and class, and that's sort of what we set about doing. And in the most recent paper, which appeared at Sigmod, Raj, who's here with us, actually showed that for things like identifying feature types, they're already underperforming really poorly compared to ground truth labels. And so these companies are actually getting scared, and they're noticing this, and Google and Amazon are collaborating with us on this to understand how to improve their things. There is a huge scope here for creating a suite of benchmarks that are very important tasks, like deduplication is an important task. Standardization of values is an important task. Extracting numbers from strings is an important task. So these are sort of important tasks. Some of these tasks we identified in our vision paper for the ML Data Prep Zoo, but there's literally dozens to even hundreds of tasks. So what is your take on this space? Why is there no suite of benchmarks, and what are the bottlenecks? My understanding from that panel discussion, two things was people are worried, okay, we can't just pick 5 or 6 tasks. It's going to be hundreds. We can't pick hundreds, but you can't make the perfect the enemy of the good. You have to start somewhere. So maybe start with a dozen tasks. The second question was realistic data sets, getting them from enterprises, it's very hard. They're not going to release data sets that are in the wild. Kaggle and stuff is great. It's the first step towards it, but actual in the wild data sets is very hard to get. And they were worried that if we do all this effort to try to collect these sorts of data and create this in publishing is very hard. And this is a first-hand experience. Even Raj's Sigma paper, we went through 4 rounds of rejection before it got accepted at Sigma. We went to VLDB, we went to KDD, we went to MLSys. No one appreciates creating benchmark label data sets. And so only this year, VLDB had this benchmarking category added to EAP, and NeurIPS launched their data sets and benchmarks. So I think things are changing just now. So I'd like to hear from you, Renee, and also from the other panelists.
Yeah, I think, well, just historically, one of the reasons for this is that we do work on data that has a lot of value, right? And so when I started out, the old adage was that database researchers are like the only ones who can't actually get real data, right? Because the data that we study has value to people. So you have to sign a bazillion NDAs to get a hold of it. And so it's very hard. So I think in the early days, that's why people went to the synthetic data generators, right? For TPCH, you generate something that's synthetic but realistic. And to some extent, the work that we've done on BARD and iBench in the data cleaning space kind of follows that. You start with some real data, and then you provide mechanisms for injecting known data prep errors of different complexity. So I think we're getting better on that side. But as anecdotally, I'll tell you, the iBench paper was also, I think we submitted 3 or 4 times before we got it accepted, because people said, oh, why do we need a data generator, right? So I think we do need to educate our community a little more, that a really well thought out, thoughtful labeled data set for a general enough problem is a good contribution, is an excellent contribution to our conferences and our journals. So I think part of that is education. And the other thing I'll say, I think it's the right time for this, because we no longer study enterprise data, right? And so when I started studying data lakes, my group, we started by crawling all the open data in the world, right? And we did that because nobody's going to give us their company data lake. But because all this open data is out there, this open structured data, because we have web tables, information extracted from web pages, these are rich resources. And I think people have started in the semantic web community publishing labeled subsets of like web tables for different tasks. And I think the database people need to do more of that with open data, with scientific data that's non-proprietary. Yeah, I think it would be valuable contribution to the community.
Paolo,
use your hand.
Yeah, I would like to make a quick comment on this because it's close to my heart. So I think that I'm with Renee on the fact that it's a matter of community, but I think that I would like to argue about this problem with analogy with this paper that was the best paper in ACL. So I keep going back to this other community because I'm impressed by how they like things that we need, but we don't do. So for example, here they are testing this BERT model, which is already something that we don't have. Like they have BERT to study. We don't have this perfect, gigantic, commonly used data set that will be, okay, you're doing this on the right data set, we're going to trust you, everybody's using it. So that's a big problem that we have. And then also in this paper, they build a lot of micro tasks that Arun was suggesting, which I love because you go through them and they're very smart and they touch different points. But the point is that in that setting, they can create automatically the test with some smart ideas. In our case, as Juliana also was pointing out, I believe we need an army of good people of goodwill to go over there and do the annotation. And finally, the community again, this paper was the best paper at ACL. And it's a paper that I doubt that an analogous paper with a big data set and similar task would be accepted because there is no key contribution, there is no innovation, you know, all the points that are touched along these ways, maybe in an experimental track now. But I think that those are challenges that are with us and we need to think a lot about how to overcome them.
Yeah,
that makes a lot of sense.
Yeah, I just want to add so sorry, you can go ahead.
Oh, yeah, so I agree with what others have said. Actually, a lot of this is costs, right? Juliana had a comment in the chat, right? The cost of labeling a table and even understanding it is orders of magnitude larger than tagging a dog or a cat from the image. So, actually we had first-hand experience when we do error detection, right? When you get a lot of data from the wild, sometimes even as data people, we don't fully understand the semantics and it's hard to judge whether a particular value is correct or not. But on the other hand, I also think we are seeing a lot of progress. For example, entity matching, right? Magellan and that project from HighScoop has created a lot of benchmark data sets, and that's kind of enabling us to make a lot of progress in the field by doing a lot of rigorous comparisons and evaluating different methods. Yeah, and also relating to that comment of benchmarking for AutoML. So our experience actually using Kaggle, for example, for finding data errors and trying to do smart featureization or transformation in the hope of improving accuracy, actually wasn't very successful. I mean, so I was thinking maybe to some extent the ML community, they take a clean data set as their starting point, right? So there's not a lot of scope for data cleaning or feature manipulation, but it really comes down to a very different set of operators. Even if we are all talking about data preparation, I think the operators that you would care about in a data analytics or business intelligence environment would actually be quite different from those that you would care for Kaggle-like tasks, which are already very clean. So that's my
that makes a lot of sense. I think the data prep space is so diverse. The thing that you mentioned, there's this whole spectrum of user base, right? The tasks for people who are working with Excel is very different from the tasks that AutoML platforms want to do, which is you have this automated pipeline and you build models for the end user, that sort of stuff. I think there is scope for different kinds of benchmarks, at least in the AutoML context. That's the one we were interested in. There is a little bit more tractability because we know what the data is being used for, what the prepared data is being used for. Whereas in a BI context, in a Tableau or Excel context, you don't know what they are using it for. It could be an open-ended data enthusiast, right? So the benchmarks there cannot be so closed form, if I were to put it that way. I think there has to be some other forms of evaluating them. And user studies cannot be, you cannot escape user studies when there's a human in the loop, right?
I mean, that's a good point. I think one of the differences of the current situation to previous ones where, I mean, we are using a lot like BART and Magellan and all these sets for like at least preliminary studies on when we create new algorithms for cleaning and so forth. But when you think about the use case, machine learning, it becomes a bit convoluted, right? So where would you set up the the goal of the benchmark, right? So what is the end goal of the benchmark if you have the use case in mind? And where do you start? So what do you think would be a good starting point to say, okay, that's where the algorithm should start? Does it start from extraction, or does it start from the embeddings? So where should it start?
That's a good point. So the thing to note is for the algorithm building and hyperparameter tuning, there are already benchmarks that the data mining and ML folks have studied. And so we can actually fix those parts as black boxes. And so we've spoken with Google and Amazon about this. They already have internal AutoML benchmark suites. So they say, give me the prepared data, and then we have 100 kind of downstream tasks where we run these things, and then we evaluate which AutoML pipeline is better. The approach we took was kind of inspired by that too, which is like, let's fix both ends of the bias variance trade-off spectrum, complex models and simple models, and multiple kinds of featureizations. And then the AutoML box that does the algorithm and the feature engineering and hyperparameter tuning, you would iterate through all of them, and then you get the best one. So really then once that is conditioned away, it's really the data prep part that differentiates things. So that's sort of the early stage approach we took. But in the end, I think going back to a point that was made earlier, data cleaning and prep affects ML accuracy too. So maybe if you do some form of data cleaning, some other form of feature engineering is not needed, right? Or vice versa. Like if you use a transformer directly on tabular data to get an embedding, this is a point that Luna made at the panel too. Forget preparation on tabular data. Treat tabular data as if it's a text, but it's just very richly structured text. Have a transformer read it. Produce a numeric vector embedding and then predict with it. She asked if that is possible. I mean, it is kind of interesting. At the end of the day, everything that we look at in a data file is still text. The numerals are text. The commas are text. The white space is text. So, but the bottleneck comes back down to the bias variance trade-off. If you use rich models like transformers, you need enormous amounts of label data. And so a lot of the human intuition that goes into data preparation and cleaning constrains that hypothesis space, and therefore you don't overfit too much. And that's a very interesting new trade-off space we are seeing at the intersection of data prep and ML theory. I think that requires a lot more study too, both from the database standpoint and from the ML standpoint. Anyway, yeah. I'll be quiet now.
Yeah, I mean, are very important points, right, as you mentioned. So we have another comment by Mohammed. Why we are putting much weight on whether benchmark would be accepted, just create the benchmark, and if people use it, that's good enough, right? I guess there's truth to that, but we need to also get paid, right? So we are professors at universities, we need to publish papers. So I guess that's one of the reasons we are not doing it all the time.
And full professors may have that option of not publishing, but I think our community needs to reward work we value. It is the basic issue.
Yeah,
so we have
about 5 minutes, right?
Yeah, we have 5 minutes. So if I don't see any more audience questions. So I'm just browsing. No, we don't, right? So we have talked a lot about the benchmarks and how we could get better at it. So what are your thoughts on all the other metrics that are becoming more and more important in this phase, like things like fairness, privacy, and now help me with the other dimensions, like these additional dimensions that come with accuracy that are also being taken into account more and more. To which extent is it part of the data preparation pipeline, and can we solve it in a similar way?
Yeah. Yeah, I think I can, start. So, I also have a line of work that work on data fairness. So, my angle is that, fairness or bias issues is a kind of data quality issue. Your data is there in a tabular format, right? And it has, inconsistencies which are traditionally treated by integrity constraints. Well, you can use same kind of logic to detect the bias in the data if those kind of bias or kind of, inequality can be expressed in certain kind of logical format. In this case, data debiasing becomes, data repairing exercise. And we've already seen a best paper award in SIGMOD, I think 2019, right? Which modeled the data debiasing process as a data repairing process. And our group is also doing similar things of trying to leverage our prior work in integrity constraints to try to express individual fairness constraints to try to repair data toward being more fair and unbiased. And I think, yeah, that definitely database could help in data fairness angle, of course.
Okay, so we have only 1 minute left. I think we have more to discuss. If we went to each point like in more depth, everybody would have some more to say. But unfortunately, the time is just over. I would like to thank all the panelists and the audience who participated, and also I hope that there were new insights and points that we can take for the research on this area.
And thank you, the organizers, for putting this group together. Thank you.
Thanks all.
Thank you very much.
Yeah, thank you.
Thank you all.
Everybody, cheers.